All right, this is lesson 7, solving linear systems using matrices. Our essential question is, how can matrix row operations be used to solve a system of linear equations? Okay, and here is our table of contents. Okay, so we're going to be talking about matrix row operations, understanding how they work, solving linear systems of equations using matrices, using technology with matrices, interpreting what we find, and applying a linear system with three variables. Matrix row operations. So there are three basic row operations. Row operations can be applied to a matrix to create an equivalent matrix. So there are three basic ones, like I said, switching rows. Okay, so I can take my top row and move it to my bottom row and vice versa. Okay, it allows you to switch a row with any other row. You can also multiply or divide any row that you want by a non-zero element. Okay, so in this case, I multiplied my top row by 3. Okay, and then I divided my bottom row by 2. You can also add or subtract a row from each other. So adding elements of a row to or subtracting them from elements of another row, it produces a new row, which you can use to replace one of the two rows you just combined. So in this case, I did row 1 plus row 2. Okay, and you can see in the top, okay, I have A plus D. Okay, so that's that new row that I just formed by adding A and D together, or row 1 and row 2. Understand row operations on a matrix. So if I'm understanding row operations on a matrix, I'm wanting to know what the solution of the system of linear equations, 3x minus 2y equals 25, and 2x plus 5y equals 4. Okay. Each equation corresponds to a matrix row. So my first equation, 3x minus 2y equals 25, corresponds to the first row of my matrix, 3, negative 2, 25. 2x plus 5y equals 4 responds to my second row, 2, 5, 4. Okay. Now I'm going to start manipulating these equations. So the first thing I'm going to do is I'm going to take row 1 times 2, and I'm going to put it into row 1. Okay, that's what this means. So row 1 times 2, and I'm going to put it into row 1. And I'm going to multiply row 2 by 3. Okay, so when I do that, 3 times 2 gives me 6. Negative 2 times 2 gives me negative 4. 25 times 2 gives me 50. For my second row, 2 times 3 gives me 6. 5 times 3 gives me 15. And 4 times 3 gives me 12. Okay. What I'm trying to do is notice that I have 2 6s here. Okay, so when I go to add or subtract rows, I can now eliminate one of my variables. That's the whole goal. You're trying to eliminate a variable. Okay. So in this case, I'm subtracting row 1 minus row 2, and I'm going to put it into row 1. Okay, so I did that. 6 minus 6 equals 0. I got negative 19 and then 38. My second row stayed the same. It didn't change. It's still 2, 5, and 4. Okay, then I divided my first row by 19. Okay, that's giving me the 0 and the 1. Okay, I want that so that I can figure out what each of my variables means. So in this case, I know that y equals negative 2. Okay, then I'm going to multiply row 1 by negative 5. I know I just figured out that y equals negative 2, but I'm doing this so I can eliminate my y values so I can have an x value. Okay, so I multiplied row 1 by negative 5. Row 2 is staying the same. Row 1 staying the same. And then I'm going to add row 1 plus row 2. Okay, so 0 plus 2 is 2. Negative 5 plus 5 is 0. And 10 plus 4 is 14. Okay, then I can divide both of my rows. I can divide row 1 by negative 5, which I've already done. I multiplied it before. Okay, and then row 2 by 2. Okay, so then I'm getting 0, 1, 1, 0. Okay, That's what we want when we solve an equation, when we look at a matrix. Okay, we want zeros and ones on this side of our dashed line. Okay. I'm going to then switch row 1 and row 2 because I want them in order for variables. So I want a 1 first because that represents my x values, and then a 0 because that represents my y values. And then for the next row, I want 0 and then 1. So the solution for this equation is my x values are 7, my y values are -2, or I could write it as 7, -2. Solve a linear system of equations using matrices. The process of solving a linear system of equations using matrices involves using those row operations that we talked about. So switching rows, adding and subtracting rows from each other, or multiplying and dividing by a non-zero. Okay. And what we're getting is called a reduced row echelon form. Okay, so we're getting each variable representing one number. Okay. So in this case, 1, 0, 0, A, 0, 1, 0 is B, 0, 0, 1 is C. So in this case, I'd write my solution as A, B, C, whatever those values are, or I could write it as X equals A, Y equals B, Z equals C. All right, so if the solution, I want to know what the solution of the system of linear equations is. X plus Y plus 2Z equals 13, 2Y plus Z equals 5, and 2X minus Y equals 6. Okay. I'm going to change that system of linear equations into a matrix. So I have 1 plus 1, 2, and 13 in my first row. I have 0 because I have no X value, 2, 1, and 5 for my second row. And then I have 2, -1, and 0 because there's no Z value in that equation, 6. Okay, now I'm going to start manipulating. I'm going to rename each of my original rows in the matrix. So I have A, B, and C. Okay. From there, I'm going to manipulate them. So either by multiplying, dividing, adding the rows together, or switching rows to get this into reduced row echelon form. I'm going to multiply my first row. So 1, 1, 2, 13 by 2. That's going to give me equation D. Then I'm going to subtract C minus D to give me a new equation E. So again, C minus D. So 2 minus 2, 2 minus, or -1 minus 2, 0 minus 4, 6 minus 26. There are hundreds of ways to do this, by the way. So if you found an easier way or there's something else you wanted to do first, you can absolutely do that as well. Okay. My goal, again, is to try to eliminate a variable. And in this case, I want to eliminate 2 variables. So I get to just having 1 left so that I can substitute those values back in to find what I'm missing. Okay. The next thing I did was I multiplied 4 by row B to get row F. And then I added row F plus row E to give me G. So notice that gives me a 5, 0, 5, 0, 0. Okay. That means I got one variable isolated. That's great. Okay. From here, I'm going to divide by 5. Okay, that gives me H. So now I have 1 done. I know that my Y value is going to equal 0, which is great. Okay. From here, now I can start manipulating what I know to get rid of another variable. In this case, I'm multiplying H by 3 because I noticed that if I multiply by 3 and I still have that -3 in that E row, I can eliminate that variable and get -4 by itself. Okay, which I do. I plus E gives me J. Okay. Then I divide J by -4 and I by -3, or by 3 to get back to my values of 0, 1, 0 and 0, 0, 1. Okay. These bottom two rows are in reduced row echelon form. So now all we have to do is the top row. Okay. I'm going to divide D by 2 to get back to A because that's values of 1. Okay. Then I'm going to subtract A minus H to get me L. Okay, so that got rid of one more variable. So now I have an X and a Z. Then I'm going to multiply 2 times K, which was my bottom row, which gives me M. Okay. And then I'm going to subtract L minus M to get me N. So now I have 1, 0, 0, 3. Okay. This is almost in row echelon form, right? Because I have this 2 at the bottom. So I need to get rid of that 2. So I'm going to divide again by 2. So my solution then is X equals 3, Y equals 0, Z equals 5, or I can write it as 3, 0, 5. You can always substitute these values back in and see if they work. I can put 3 in for X, 0 in for Y, and 5 in for Z into each of my equations, and I should get 13, 5, and 6 respectively. Use technology with matrices. Okay, so once you have the ability to set up a matrix with your systems of equations, you can use technology tools in order to help you solve them. Okay. So what is the solution of the system of equations? X minus Y equals Z, 4X plus 3Y plus 2Z equals 6, 2Y minus X minus 3Z equals 13. Okay. I'm going to change the equations so that they're in standard form and then put them into a matrix. So with this first equation, X minus Y equals Z, I moved the Z to the left side of my equation. Okay, so that's where I got the 1, -1, -1, 0. The second one was already in, so that was fine. 4, 3, 2, 6. The third equation, I just had to switch the X and the Y, so it's -1 to -3, 13. Okay. Now you can either use a graphing calculator if you have one, or you can use Desmos. Okay. So in order to use Desmos, you want to go to the website, desmos.com. Okay. In the top, you'll see math tools. So you'll click on that and then you'll click on matrix calculator. Okay. Once you're at that page, you'll go to click on a new matrix. Okay. So you're going to create that matrix. And you're going to edit your matrix as needed with numbers of rows and columns that you need. So in this case, I'm going to have 3 rows and 4 columns. Okay. Then I'm going to enter each of my values into my matrix. So that 1, -1, -1, 0, 4, 3, 2, 6, -1, 2, -3, 13. And you can click on each one. You can hit the enter button. There's a bunch of different ways to do it. Okay. When you have completed entering your matrix, you're going to click on the RREF button. What that button stands for is the reduced row echelon form. It's going to get you into the smallest form possible. Okay. Then you click on whatever matrix that you just created. In this case, we created A. And then you hit the enter button. And at the bottom, it's going to come up with your solution. Okay. So, and right next to that solution, there's a little button that looks like a fraction. You can change that. It'll change it between decimals and fractions if you have any. So this is what we get when we solve it. Interpret the reduced row echelon form. So what is the solution of the systems of equations? 2x plus 4y minus 6z equals 8. -4x plus y plus 12z equals -16. And x minus 3z equals 4. So I change that into a matrix. And then I'm going to use Desmos to substitute those values in, and I'm going to reduce row echelon form it. So I get 1, 0, -3, 4, 0, 1, 0, 1, and a straight row of zeros. Okay. We can see that this gives us a solution of x minus 3z equals 4, y equals 1, and 0 equals 0. This means that there are infinitely many solutions to this system of equations. Okay. When I get 0 equals 0 in that bottom row or any row, I know that there's a bunch of different solutions that I could potentially substitute into these values. Okay. The other one to look out for is if you get a contradictory one. So if you get that 2 equals 2, like you get 2 equals 3 instead of a number. So you would get zeros all the way across and then a number in this last row. So if it was zeros from your X, your Y, your Z value, and then you got 4, that would be an inconsistent solution. Okay. Apply a linear system with 3 variables. So a party planner charges customers based on hours, guests, and tables. A record of the invoices for the last 3 customers is shown. What is the per unit charge for each element? Okay. So I had the birthday party. There was 3 hours, 20 guests, 4 tables, and they were charged $370. The McGregor retirement, they were there for 4 hours, had 25 guests and 2 tables, and they were charged $560. And then the Granger Weasley wedding was 6 hours. They had 75 guests and 16 tables, and they were charged a total of $1,130. So I'm going to use this information that they gave me and set up a system of equations. All right, so now that we have the information, what we want to do is actually take that and transform it into a set of linear equations. Okay, so when I do that, I have H equals hours, G equals guests, and T equals tables. Okay, I can then put that into a matrix. And from that matrix, I can use reduced row echelon form in Desmos or on a graphing calculator to simplify it. When I do that with reduced row echelon form, I find that it charges $50 per hour, $10 per guest, and $5 per table. And you can always check that these numbers actually work by substituting that information back into the original equations.